Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, and I'm here with Rich Nass, who is the Executive Vice President of Embedded Computing Design and Open Systems Media. I do want to make one logistical note. Laura Dolan, who joined us for several of these over the past few months, has moved on, so we wish her the best of luck, and hopefully she finds success in her future endeavors. But without further ado, how you doing, Rich?
I am doing great. How are you?
Doing well. We actually both of us got back from the RISC-V Summit, which was this past week in San Jose. A decent turnout. I think they may have wanted to stay in the Santa Clara Convention Center, but a good turnout just the same. What did you think of the show?
I thought it was okay. I think that most people will agree that there's more hype still around RISC-V than reality, but I mean, that's to be expected. And you know, I don't think anybody's disillusioned by it, but if you're in Silicon Valley, I think it's something really cool and everybody's excited about. And if you're in China, it's something really cool and everybody's excited about. But I think if you're not in one of those two places, there's more of what is this thing and why should I care?
Yeah, actually during the show, I hosted a panel. Some of the members of the panel were Chris Stasanovich, who is the chief architect at SiFive. He's also one of the professors over from Berkeley, who was one of the originators of the RISC-V ISA. We also had Mendy Firmanek, who's represented Open Power, Joseph Jacks of OSS Capital, and then Tim Whitfield, who's from ARM and was brave enough to join a panel at the RISC-V Summit. The panel itself was about opportunity and risk that's presented by open source hardware. And one of the questions that I asked Kirst was, you know, SciFive, you look at a lot of the design wins that they've had lately, and they appear like they're custom implementations for specific customers based on RISC-V technology. I brought up whether or not that was good for the ecosystem, the RISC-V ecosystem as a whole, and whether or not that was going to create any sort of fragmentation or interoperability issues in the future if they're straying into really incredibly custom implementations. And Chris' response was no. I mean, that's the purpose of an open ISA. You know, most of the interoperability stuff is going to come through the software interface. Do you think that that's true? I wonder sometimes, Rich, whether or not, you know, SciFive has so much control that they're going to do whatever they want, and all of a sudden this open ecosystem is really SciFive and everybody else.
Well, you raised a bunch of different issues, and one of them is specific to SciFive, and one of them is if some XYZ company does what SciFive is attempting to do. So let me go with the latter first. It's great for that company, but I don't think it's great for RISC-V. It has the potential to make a really good market for them, but in general, it just doesn't, advance the RISC-V spec at all.
Right.
It's just somebody with a custom solution. As far as SciFive and RISC-V, I think that's a legitimate concern, and I think that the RISC-V Association, Foundation, whatever they're called, I think that they recognize that. That SciFive is a smidge too powerful, and it wouldn't surprise me if you see something change. And I wouldn't, I mean, SciFive has been really good for RISC-V, so I don't want to make it sound like they're evil or anything. I just think that there's a point where you have to step back and say, okay, this is open source, so let's make it open source.
Right. It's also interesting that this is the second RISC-V Summit that I've attended. And we still haven't seen a big commitment from any of the major semiconductor vendors outside of Microchip, who really got involved because they acquired Microsemi, who was, involved prior. But still NXP, mum's the word. A bunch of the other semiconductor players have looked at it. There are also some mammoth players who are actually on the board of the RISC-V Foundation or members of the RISC-V Foundation, and they haven't really moved the needle in terms of any public announcements themselves. There are whispers, Samsung's looking into it, Qualcomm's looking into it, but it's always just looking into it. And what could really help drive the ecosystem forward is if one of these major players came down, spun out an SoC, and you really said they're committed to this. I think until that happens, we may end up in this middle ground where SiFive does have a lot of power, and maybe the ecosystem becomes a little bit more stagnant because of it.
It is very much chicken and egg, and I have it on pretty good authority that NXP is waiting for the ecosystem to be more robust. The worst thing that could happen is they come out with a chip and the developers can't develop with it because the tools aren't there yet.
Right.
So they're waiting for the ecosystem to improve. And I don't think it's any secret that they produced that Vega board to put in the community's hands to do just that, to enhance, build up, whatever the word is, the ecosystem. And they're just waiting for the right time. Obviously, they have a chip ready to go. It was on the Vega board, so they can do it anytime that they want. And it's really critical that they do it at the right time. So it is seen as a plus, not a, well, what do I do with this chip now that I have it?
Moving on right along, you had a topic that you wanted to discuss today that was kind of interesting, and interestingly enough, it's related to all of these custom chip implementations.
Topic that came up multiple times at the RISC-V event was looking at some of these huge vertical companies like the Amazons, the Facebooks, the Apples, and the fact that they're making their own chips. And my question that I'd like to debate with you, but I'd certainly like to hear what the community has to say about it, is that a good thing that Amazon is making their own chips and that they're not going to Qualcomm, they're not going to NXP or ST or Intel or anybody else. They're just building it themselves. And in the case of Apple, they acquired a semiconductor company to do that, to build their own ICs for their own products. Do you think that's a good thing?
I don't know if it's a good thing, but I mean, it depends what, from where you sit. If I'm, Jeff Bezos or anybody who's in charge of a public company and I'm looking at the bottom line, yeah, why wouldn't Amazon or Google just create their own semiconductor development division and build these chips that are specific to their use cases? I'll put Apple aside for a second, but Google and Amazon are building these massive data center platforms that are used to accelerate certain types of workloads and are really finely tuned to the requirements, not only of the workloads that are coming through, but the cost efficiencies of the data centers that those companies own. So if you can just scoop up a bunch of semiconductor engineers, SOT architects, EDA specialists from around the industry, why not do that as opposed to the overhead of outsourcing these designs to a third party, especially when you have the means like these companies do. I mean, Google, Amazon, Intel, companies like this, they acquire companies a lot of times just to either gut them for their IP or to have a path forward in case the market takes any sort of turn. Why not just bring all of that in house? It's not like they don't have the resources.
Wouldn't it be interesting to be in a meeting at Renaissance where the product manager comes in and says, Amazon just decided not to go with us. They're going to build their own chips, and by the way, they need 30 million of them.
Yeah, I mean,
it's just a weird situation.
Well, why? I mean, isn't that just the tech world? That's tech business, right?
I guess. It sort of brings me back to probably before you were born. The original PC was built 100% by IBM. They built the microprocessor, they built the hard drive, they built the memory, they built every aspect of that computer. And it wasn't till far later that people started building the individual components. And it sort of seems like the same thing.
Well, I mean, Amazon isn't out there building its, backplanes and enclosures, is it?
No, but they're building chips and they're producing products with their own names on them.
Yes, they are. You know, you also have to look at it from the other side. Yeah, the semiconductor companies that aren't building those chips are missing out on tons of revenue, and they're probably getting a bunch of their, brightest minds vultured away from them. But
Yep.
on the other hand, it's not that Amazon or Google are going to the marketplace and directly competing with those companies either with the chips that they're creating, at least not right now.
The thing you said right at the end, at least not right now.
Hmm. Well, yeah, and they're going to start at the high end. So I think that most of the people in the embedded space that we deal with on the day to day, if it wouldn't be affected by an Amazon or a Google, commercializing their own chip. Firstly, you got to really think about what would the advantage of Amazon or Google commercializing their chips be. I think that they have more to lose by doing that than to gain. They don't want everybody else to know what the secret sauce is in their data center platforms. That's they're squeezing pennies at that point. You don't want to, out of all, the power efficiency, the acceleration, of the security, or all of those different things, that is becoming more and more what is able to differentiate them is just the economies of scale that they get out of their data centers. Why would you put that out into the market? But if they did put it out to the market, then I think that the people who would have to be the most concerned are an Intel, with their Altera-based, FPGA-based Xeon processors. Obviously, NVIDIA, they're creating these massive GPUs for those types of applications. The NXPs, TIs, STs, microchips, that they don't play in that sandbox.
Okay, the one important factor there is, as you know, it cost about $10 million to build one chip, and
Mm-hmm.
it cost about $11 million to do a million of them.
Yeah.
It's that initial investment that's huge, and after that, you just spin them out.
Yeah, but what's $10 million to Google or Amazon or Apple, even, for that matter?
Okay, what's the phrase? A billion here, a billion there. After a while, you're talking about real money.
If they're building these platforms that are hyper focused on their specific use case, how many how many Googles out there are there for Google to sell their chip to? There's not a million of them, there, and the people that are out there that may potentially be buyers are their direct competition, right?
Okay.
You're going to sell it to Alibaba and Amazon.
I'm going to leave it there because I think we could have this. We could just go round and round with this forever.
That's true.
The Insiders recently spoke with Enrico Carrieri, chair of the MIPI Debug Working Group, about 9 MIPI Alliance debug and trace specifications that are now publicly available for download.
What's wrong with the debug landscape in the engineering world today at all? Why do we need more advancements? It seems pretty stable.
Well, yeah, I think a lot of our technologies have been around for a while. I think people are familiar with UARTs and JTAG and things like that, and it's been around for a long time. But I think they're becoming not as sufficient for our needs. And what I mean by that is there's new things, our platforms and things are changing. Low power is becoming a very important thing. And integration of multiple chips and how they're talking with each other is becoming complex. And what I mean by that is you may look at it as a system that you're trying to debug instead of a single chip. And now you're having these complex interactions. Things may be powering on, powering off. You need something that's a little better at doing that. Where something like a JTAG, maybe if you're using JTAG, if something powers down, you lose your JTAG chain. You don't want that, right? You want to be able to watch those things go up and down and not lose your connection, or in this case, lose that JTAG chain. So I think we're looking at newer technologies that really go and try to solve those situations and really help with things like low power and this bigger integration and things like that. The other thing that we're also looking at is more of this, what we like to call this layering approach, where you can build more capabilities on top of your existing capabilities or fill in the gaps between layers. And so we've been really focusing on that. And if you look at kind of our MIPI roadmap lately, we've been really focused not just at maybe the interface, but even at the higher levels near the software. And we've been doing a lot of things there as well. So we've been really trying to focus on a lot of these different things because these are the gaps that we see with our traditional, maybe like I said, the JTAG or some of the other methods that people have been using over time.
So I know that you there's a spec from MIPI Tiny SPP. Can you tell us a little bit about that and what your plans are for pushing these specs into the market?
Yeah, absolutely. So we had our sneak peek protocol specification, and that has been around for a little bit, and it's a debug communication protocol that we put on top of other interfaces, and we've been putting it over USB, Internet Protocol sockets, and things like that. But as I mentioned earlier, low power is becoming a really tough thing to debug, and we've been looking at more low power friendly interfaces where, but those interfaces are not as maybe high bandwidth as something like USB. So for example, we've been really looking at utilizing one of MIPI's other specifications, I3C, as a debug channel. And I3C has a lot of interesting properties, like being able to handle when devices power down and having multiple master capabilities and things like that. But one of the problems with Sneak Peek as it was, and what we would need for something like I3C is things like lower bandwidth and higher latencies. And so what we did is we basically optimized the Sneak Peek protocol. We called it Tiny SPP because it's smaller, because we didn't have the kind of bandwidth in something like I3C versus USB, right? And so we've kind of made it a little tiny and optimized for those kinds of interfaces. So when you want to utilize some of these lower power interfaces or these maybe smaller, right? These smaller interfaces, some products, especially like in IoT, you don't have these big, huge serial IOs. You're not going to have those kinds of things available sometimes. So we're really trying to focus on those kinds of things. And that was what Tiny SPP really did, was really optimize for that, but yet still have the goodness that Sneak Peek provided.
You guys are opening some of your new specifications up to the public. What's the intent there?
A lot of maybe ASIC designers or chip component makers, they're using our specifications, and they're putting in the hardware for things like I mentioned, the Sneak Peek or some of the trace protocols that we have. But debug hardware is pretty useless without having tooling and software to go with it.
Right.
And what we found is to create, we believe, and we're hoping, that by providing the specifications, it makes it easier for these tooling vendors and software creators to go help create that ecosystem. They're not necessarily creating any hardware, right? They're not creating the actual silicon or whatnot that requires the spec, but they need to understand what that hardware may be doing so that they can create that tool and that software, right? And so we're trying to enable them to do that and really create that ecosystem where we have the hardware vendors creating the silicon, and we also have this tooling and software vendors creating the other half of the system. You know, I work for a company that creates all this silicon, right? And what we really want is our customers, we give them that piece of silicon, right? And all of our members, MIPI members, they're going to give this piece of silicon. And when they give them to the different customers, we want the customer to be able to just go to the market and say, oh, I am going to buy tool, I'm going to buy tool A from, I can buy tool A from X, Y, or Z. And what that really does is if I enable that ecosystem at the end of the day, it will drive cost down, as everything as we know, right? If there's competition, that's going to drive the cost down. And debug is one of those things that you really don't want to spend money on, but you know you have to because it's that evil that you have to deal with. And so anything that we can do to drive that cost down is very beneficial across the market, right? And that's the whole thing with the standardization too, is to reduce the effort, which reduces the cost. So that's our thinking, and that's why having an ecosystem is there. Because if you're going to sit there and you're a new guy and you're building this chip, well, what are you going to do? You're going to look out in the world and say, oh, well, there's this debug solution with this tool out there. Great. I'm just going to take those two. Really cheap for me to just take it, integrate it, and go. And that's the idea. MIPI provides those specifications so that you can do that in the hardware, and then hopefully we've created this ecosystem that then the software and tooling is ready for you as well.
You know, it seems like at the same time, we're either trying to get more low power, or on the other end of the spectrum, we want way more bandwidth. How do you see interfaces evolving over the next 5, 10, 15 years? Should design engineers be looking at new debug interfaces, the physical interfaces that they're going to have to be working with?
I think so. I mean, if I look at it, there is that dichotomy, right? You have the low power and you have the high bandwidth, right? And as we probably all know, trying to do them together is going to be very tough.
Right.
And usually the way we've been approaching it is to say, well, let's go back to that example with Sneak Peek. So I have Sneak Peek, right? And we have other ones for Trace that we have a overarching protocol. But what we've done and what we're doing now is really looking at it and say, well, if you need the high bandwidth, we can do Sneak Peek over like USB and providing USB. But if you need Sneak Peek over some low power, I'm going to give it to you over I3C. And from the tooling aspect, it's still Sneak Peek. It doesn't matter how I connect and how I get it. That's just a transport. Who cares? The real data is the Sneak Peek data, and that's the same no matter which interface I take it out of. So we're trying to, and this goes back to what we call our layer approach. We have that layer of Sneak Peek that's common, but maybe your interface is different, and that's okay. And that's what we're trying to do is say, look, you find the best interface that you need for your product. If you're an IoT little sensor, maybe I3C is the best thing for you because you're that low power and you're that small, right? Something like USB doesn't make sense for you. But if you're a bigger device, maybe USB is. So we allow that. Keeping the same protocol, again, the tooling sees it as I don't care what interface it's coming from. The more flexible you are, and the more you can abstract things and have this layered approach, I think it'll be better for the implementers and users of it.
And now time for Things That Annoy veteran software engineer Jean Labrosse, architect of the Micro C OS RTOS.
Many years ago, I've asked one of my software engineers that worked for me to follow our company coding standard, which happens that I wrote those coding standards. But the programmer told me, hey, dude, software is an art. I like to be creative with my code. So I kind of told him, like, look, first, it's not your code. It's the code of our employer. And then second, how about if I paid you the salary of an artist as opposed to an engineer? So, of course, he didn't take that too lightly. But I eventually ended up firing him for that and other reasons. I believe in the long term, whatever he produced would end up being costly to maintain, and in fact, nobody wanted to inherit his creations.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.